Hi everyone, in this video I'm going to talk about the difference between a z-test and a t-test and then show you how to do a univariate t-test and how to analyze the results from this. So when we are dealing with metric data with one sample, we can run a z-test. This is used to determine whether two population means are different when the variances are known and the sample size is large. So we're dealing with the sample size being greater than 30. The test statistic is assumed to have a normal distribution and parameters such as standard deviation are known. So the assumptions within the z-test is that you know what the standard deviation is. However, in terms of what you need to know for running a z-test for a t-test, use the t-test when the population distribution is normal but the population standard deviation is unknown, and all for samples that are less than 30. So the t-test is the more conservative test versus the z-test. However, you don't actually need to decide which one you are going to run, because SPSS and PSPP only offers t-test procedures that have magic in their coding, and they will compute the right test based on the data that you have provided it. So essentially a z-test and a t-test, for all intents and purposes of what we are doing, they are essentially the same thing. So, a one sample univariate t-test. So this is when we use this test to compare the mean of one sample's metric variable against a specific mean or a comparison value. For example, if we wanted to know whether people's perceptions of price competitiveness are higher or lower than the average perception of price competitiveness, or in another case you can also do comparisons between how a company does in terms of time of service versus in a particular time period, say a week, versus the average or the mean of time to serve people over a year. So we can then track whether time to serve in the previous week is significantly above or below the yearly average. So the possible hypothesis that we are dealing with here is the null hypothesis, is that the difference between the variable mean and the comparison value is equal to 0. We have two different alternatives hypotheses that we can use. We have one tail hypothesis in t-tests where we are dealing with upper tailed alternative hypothesis assumes that the variable mean of the sample is greater than the comparison value, or the lower tailed alternative hypothesis that assumes that the variable mean of the sample is less than the comparison value. So one-tailed hypothesis is where you are testing to see whether we are higher or lower than the comparison value, whereas a two-tailed alternative hypothesis is essentially that the difference between the variable mean and comparison value is not equal to 0. So rather than being higher or lower, the two-tailed hypothesis is looking for overall difference. So the two-tailed is more conservative and it's the more commonly used hypothesis. So the example I'm going to use in terms of demonstrating how to do a univariate t-test is from the Delhi Depot data that is available on Wattle. So the question here is, do customers consider Delhi Depot's prices to be average? So the one sample that we are using is Delhi Depot's customers. The metric variable that we are testing is competitive prices, and the comparison value, or the specific mean that we are testing, is the midpoint between 1 and 10 on the measurement scale used in the survey of competitive prices. So this is what we would call a theoretical mean, as in the midpoint between 1 and 10 becomes the theoretical mean, or the average of which we are comparing the customers of deli depots' perceptions of price competitiveness against. So the procedure that we are using here is that we are going to we analyze, compare means, one sample t-test, and the various procedures. However, if I go, wrong window, I've been playing around. So here we go, analyze, compare means, one sample t-test. And the test variable I want to look at is competitive prices. So I select competitive prices, I select the arrow which puts it into my test variable. Here I also change the test value. This is the comparison value in which the t-test will be run. So it was 5.5. I just want to check my options to make sure that the confidence interval, so my reliability statistic that I'm going to be using is 95%. So I say OK. And I say OK. So here we have the output that emerges in our output window. I have put it into here so I can show you the various steps. So in terms of the analysis of the univariate t-test, so first thing we need to do is the hypothesis test. So here we look at the t-test statistic and the significance level. So that is in this red box here, where we have t, the t value is minus 40.713, and the significance level is 0.000. So because 0.000 is less than our cutoff of 95% confidence of 0.05, the null hypothesis is rejected, and the alternative hypothesis that there is a significant difference between the variable mean and the comparison mean is accepted with a high level of confidence. The next thing we need to do is actually look at what the meaning of this difference. So therefore, the next step is interpretation. So remember that the comparison variable was the average of the competitive prices of 5.5. And then we look at the mean. We can look at the mean difference, or we can look at the mean. So these two red boxes show us the numbers that we are looking at. So the mean difference here is showing us how far, in this case it's negative. So it's negative 3.28 below the competitive prices of 5.5, and the actual mean is 2.22. So what we can say here is that the mean of respondents' perceptions of deli depots' price competitiveness is significantly less than the average. Or we could say the average answer is closer to the anchor point on the scale. So it's closer to being 1, not competitive, than it actually is to the midpoint on the scale. So the conclusion we can draw from this is that deli depots' prices are perceived to be uncompetitive. However, we cannot make any conclusion as to why this might be the case. Are prices too high? Is the quality lower than competitors at the same price point? That is analysis that needs to be done on different sets of data using different sets of analysis. So that is the difference between a z-test and a t-test, and how to run a univariate t-test. In the next video, I will discuss independent sample t-tests, where we have metric data and 2 independent samples.